Bluetooth is absolutely everywhere. If you go and buy wireless earbuds, wireless headphones, they're usually Bluetooth. You buy a wireless keyboard, wireless mouse, it's usually Bluetooth. Bluetooth is everywhere, and everybody knows that you can go to the Bluetooth menu on your smartphone or your computer and see what kind of Bluetooth devices are in the area. But what if I told you there is a hidden world of Bluetooth enabled devices that you can't see from these menus? There is a hidden network of embedded systems, Internet of Things, that is using a Bluetooth communication system that you just can't see. Why even bother with this? Well, the upshot of this is that if you have all sorts of embedded devices around the place that need to be talking to each other and doing different things, but you don't really want to clutter up the experience for, users who just want to connect their headphones, that's why you have this whole Bluetooth low energy thing. It's a network for embedded devices that they can talk to each other without interfering with the experience of a user who just wants to connect their headphones. So in this video, we're going to talk to you about what Bluetooth Low Energy is, how to access this hidden ocean of devices, and how you can actually write your own Bluetooth Low Energy applications. This layer structure is the first thing I want to talk about in relation to Bluetooth Low Energy. And guys, I know the layer stuff is really boring. We're going to get through it quick, and then we'll get to the interesting stuff. So there are three overarching layers that you need to be aware of when you're developing Bluetooth Low Energy applications. And those three are the application layer, the host layer, and the controller layer. So the application layer is where your application actually does stuff with the Bluetooth messages that you receive. So for example, if I send you a Bluetooth message whose intent is to turn the lights off, then the application is where I actually see, okay, you've sent me a packet that says turn the lights off, let me go and do that. The host layer is where you actually develop a sort of service hierarchy. That's this generic attribute protocol stuff here. You'll develop a service hierarchy for your Bluetooth services that you want to be exposing, and we'll get into that later. How the connection is actually negotiated, like who initiates the connection, what connections can be formed, that's this generic access profile thing that we'll also talk about. Whether or not pairing is involved, that's where the security manager comes in. And so that's the host layer. Below that, we have the controller layer, which is where things are actually sent over the wire, or I guess over the wireless. So what we're going to talk about in this video is primarily this host layer, because if you're developing Bluetooth Low Energy applications, you essentially are acting as the host, and you'll have this thing called a host controller interface, which is the thing that actually gets the host, which is you, to talk to the controller. The vast majority of the time when you're developing Bluetooth Low Energy applications, you'll be working as the host, so that's what we're going to talk about today. With that boring stuff out of the way, we're going to do something fun. So what I want you to do is get out your smartphone and look up NRF Connect for mobile on your application store. This is a Bluetooth Low Energy scanner, and what we're going to do is use it to identify the Bluetooth Low Energy devices that are all around us, so you guys can get a sense for how many devices Bluetooth Low Energy actually works on and that are broadcasting in your area that you don't even know about. So I'm going to open up the application, and what I'm going to do is scan for the Bluetooth devices that are in my area. So, I can click on them, I can open up individual ones and have a look through. And if you just have a look through the Bluetooth Low Energy devices in your area, you'll get an understanding for how many there are. There are so many, and you can identify all of them. This is just in my general vicinity right now. You can identify all of them with the NRF Connect app. And we're going to be using it to prototype and test some of our Bluetooth services later on in the video. What I have with me right now is a Bluetooth Low Energy beacon. Have a look at this, guys. You've probably seen this or something like this before. This Bluetooth Low Energy beacon is the first type of Bluetooth device that we're going to talk about because it directly maps to what we were doing in NRF Connect just before. So these Bluetooth Low Energy beacons, what they do is they are constantly broadcasting an advertisement packet, just like we saw in NRF Connect. But they are non-connectable. What this means is they are broadcast only. Why would you need a broadcast only beacon? What's the point? Well, think about AirTags. Apple AirTags are actually an example of broadcast only Bluetooth Low Energy beacons. And this is not an Apple AirTag, but Apple AirTags do that. If you don't know how the Find My system works, they use Bluetooth Low Energy beacons. It's actually really cool. Instead of having a GPS chip in every AirTag, what Apple can do is have them constantly emit a Bluetooth Low Energy signal. And when a phone with a GPS chip comes in and gets that signal, it can say, I found this Bluetooth device based on the MAC address. I found this Bluetooth device, and this is my current GPS position, and that's how Find My works. Pretty cool, huh? The first part of the Bluetooth Low Energy protocol I want to talk to you guys about is the advertisement packet. This is essential to both Bluetooth Low Energy and Bluetooth Classic, but keep in mind, Low Energy and Classic are very, very different, even though they're both called Bluetooth. So this is only for Bluetooth Low Energy. Anyway, what I have up here is the Nordic Semiconductor Developer Academy. This is a really, really great website if you want to learn more and read about this stuff. But we're going to step through this advertisement packet stuff together. So essentially your Bluetooth LE packet, this is the full thing here. So if I was a controller and I was listening for Bluetooth advertisements, this is what I would get. For the application developer and working on the host layer, we are really concerned with this PDU, the protocol data unit. And in fact, the payload of the protocol data unit is what we actually really care about. So if we head on down, you can read more about this if you're interested. But if we head on down to the PDU, what we have is the payload, the advertisement address, so this is your Bluetooth address, and your advertisement data. Now, this advertisement data is where we can actually start building our own custom Bluetooth Low Energy protocols where we can put in all kinds of different information. And so the advertisement data, it's 31 bytes max. And so you'll see that number pop up all around the place. You'll say, oh, I've only got 31 bytes in my advertisement packet, blah, 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 blah. What I have here is an excerpt from the Bluetooth specification. You can see here we are on Bluetooth.com, and I'll link all of this stuff in the description, guys, so don't even stress. What we're looking at is the data types that you can actually put in this adv data field. So this is actually requiring a specific structure. It's not raw data per se that you put in this advertisement data. There are specific data types that it is expecting. So the upshot of this is that if I am a Bluetooth device that is listening and scanning and getting all of these advertisement packets, based on what the developer puts in this advertisement data, I can do different things or make decisions based on that. So for example, if I identify that you're one of my friends or one of my own manufactured devices, I might be able to connect to you or not. You can see this table here, we've got AD is the column that we're looking at. We've got some O's and some X's. So the first thing that we can put in our advertisement data is a service UUID. Now we'll get to that in the next section. That refers to a GATT service, so don't stress about it too much for now. We can have the local name of the device. So if my device's name was Samantha, I can put Samantha in the advertisement packet. And for example, if my embedded device is only wanting to connect to my phone or my computer, it can filter based on the name Samantha if it wants. We can put flags, we can put manufacturer-specific data, and this is essentially just an array of raw bytes that you can put whatever you want in there, and that's really, really useful for your own custom protocols and stuff. The transmit power level, which is typically used for beacons, because what is usually put there, if it's a beacon, is the signal strength that you get from 1 meter away. So if I'm looking at this TX power level, which is the signal from 1 meter away, and I'm comparing it to the signal strength that I get, I can see, am I 1 meter away, am I not? There's some stuff here that you can get more metadata about the device or the device's, properties if you really want it. The big ones for us are the service UID, the local name, the manufacturer specific data, and the service data. Talk is cheap, show me the code. That's a comment I got on one of my theory videos before, and to be fair, the guy did have a point. I have to be very careful about how I do code examples in this video because every platform, every system, every programming language has different Bluetooth APIs and different Bluetooth libraries. In fact, the code example that I show you right here would not work on a Mac or Windows PC even though it's written in Python because the Bluetooth platform that it's targeting is Blues, which is for Linux. The point I'm trying to get across here is that Bluetooth libraries differ so very much across platforms and even on the same platform depending on what library you use. The point is, you can't copy and paste Bluetooth code unless it's being written for your specific target platform. I know that sucks to hear, but the point that I'm trying to make here is that if you understand what's going on behind the scenes, if you understand how Bluetooth works, if you understand how all this protocol stuff works, it's very easy to map concepts to the API for the system that you're developing. The base concepts are translatable across all platforms. What we're doing is we're targeting manufacturing data. If you remember what I told you before in the advertisement packet, manufacturer-specific data is essentially an array of raw bytes that we can put whatever we want in. So the way that the manufacturing data works is you have a manufacturer ID, and in this case, this is my Hoff Industries manufacturer ID. If you can't tell, this is ASCII for H, this is ASCII for F. And so essentially, the manufacturing data will be for the Hoff.Industries manufacturer ID. And the manufacturer data Typically in here, you would put stuff like maybe the software version or maybe what features it supports or something like that, so that devices looking to connect to it, or maybe state-based information about its current state. You know, it can advertise if it's a temperature sensor, for example, it can be broadcasting the current temperature, something like that. So that's typically what you put in this manufacturer-specific data packet, is just any data that's specific for your application that only your other devices will really be able to understand. In my manufacturing data, I'm going to put cafe in hex speak, and that's pretty much it. I have a helper function, list to bytes, that takes this list of integers and converts it to a Python byte array. Again, that's like platform language specific. And essentially all I have here is this advertisement, which is how Blues expects its advertisement. The name of the device is Sunnyshore, so it'll also put my local name in there. This field here, 20, that's how long the advertisement's going to last. And here's the manufacturer data. There's other parameters here as well, but they don't really matter for this. So if I start this up, what it's going to do is essentially broadcast my advertisement packet with cafe in it with hof.industries as the manufacturer ID. So let me go ahead and do that. If I start advertising here, and ignore this, this is essentially just saying that transmit power is not implemented in Blues yet, which is fine. We're not even bothering to add that. So if I then grab my phone and I go to NRF Connect and I scan, and I'll see if I can show you, I'll pop it up on the screen as well. And here's the packet that we received from NRF Connect. Over here on the right-hand side, what I have is the documentation from the Zephyr project, because what they've got is hash defines for all the different types of data, so we can look at this and sort of map them and see what's going on. So let's step through this together. The first thing that we notice immediately is we've got this raw data up here, which is our advertisement payload. And here it's got a breakdown of everything that it managed to extract. So the first thing we see is we've got a length, a type, and a value. And if you map that to the raw data, you'll see the length is this OXOF right here, because OXOF in hex is 15 in decimal. You've got the type, and if we have a look over here, we can try and find out what type that is. So if I just probably do a search for OXFF, you'll see BT data, manufacturer data. And so that's exactly what we want it to be, right? We said in the code we want this to be manufacturer data. And the value here is exactly what we expect. We've got 6668. Actually, I think I got the endianness wrong. It should be 6866, but you know, it's all good. And then here's our array payload that we had that we can modify and do whatever we want with. So you can sort of imagine, instead of cafe here, I could have put anything useful about my application. So in an embedded system, depending on what that system's designed to do, I can put any number of state information. Since this is coming from my big desktop computer, maybe I could put current CPU load in there, and I could find that useful in some wall-mounted display or something like that that uses Bluetooth Low Energy. The possibilities are endless. You can put whatever you want in here and have it broadcast out to the world. Let's have a look at this next one here. So we've got the length, the type, and then the value. Let's look at this one. So this is a length 3, so it starts over here. We've got the type OX19. Let's find out what that is. So if I scroll back up and we'll try and look for OX19, that's BT data gap appearance. And so gap appearance is actually a way to generically categorize a device right from the offset. And what I've got over here is this documentation by Texas Instruments. I'll link in the description if you're interested, but it's essentially a define of all of the typical gap appearances that your device can have. So, if you want your device to advertise itself as a clock, a computer, a display, blood pressure, barcode scanners, stuff like that. For our purposes, it's 0, sort of like undefined, because it's our own custom thing, right? We don't really care. Then over here, and you'll notice this length field applies for the type and the value, because we've got 1, 2, 3. So the length is actually for the type and the value. Next on the list, we've got this length 2, OX01. So if we have a look at OX01, these are our advertising flags. What that means is essentially, is this a connectable packet? Is this a non-connectable packet? And various other things like that. The last one here on our list is this type OX09. So what's this? If we scroll down here, you'll see BT data name complete. And what this is Sunnyshore in hexadecimal. If you remember, we called this computer Sunnyshore because that's its name. So we're advertising the name of the computer in here, and that's how you can see it pop up here in NRF Connect. It's got the name in the packet as well. So this is our advertisement packet. And yeah, you can make this whatever you want. What we've been talking about so far is a Bluetooth Low Energy paradigm known as connectionless communication. And what you'll notice about that is that our devices don't have to form any kind of formal connection in the sense you're used to with when referring to Bluetooth. They're essentially just broadcasting information about themselves, and we can just passively pick that up and do something with it. And that's really useful. You can do a lot with that, and you don't have to form any kind of formal connection at all. But there are limitations with this, right? The first big limitation is obviously the 31 byte payload. You're very limited by that. If you want to stream any kind of data over Bluetooth Low Energy, you can't really do that in the advertisement packet, or you can, but it would be seriously difficult. We have this idea of a formal Bluetooth Low Energy connection that adds a whole lot of functionality that we might want to use, and that's what we're going to talk about now. The name of the game when it comes to Bluetooth Low Energy devices and them performing different roles is the GAP, Generic Access Profile. This is very common. You'll see this terminology used all over the place. There are 4 GAP roles that a device can be performing. There's the broadcaster, the observer, the peripheral, and the central. Now, if you're switched on, you'll realize we've already covered 2 of them. The broadcaster is the whole beacon thing that we were just discussing with non-connectable packets, advertising packets, and the observer is something like NRF Connect, which is just listening for these packets and doing something with them. The peripheral and the central roles are used in forming connections between devices. So one thing that you'll have noticed me mention when we are talking about the advertising packets is that you can actually have a connectable advertising packet. And what that means is that the device will allow another device to connect to it. The peripheral device is the one that actually advertises its connectable packet. So if I have a Bluetooth peripheral in the GATT peripheral role, I'm advertising a connectable packet, and a central is the one who's going to look at that, identify it as a connectable packet, and initiate a connection. So a peripheral device is constantly advertising a connectable packet saying, hey, look at me, you can connect to me, I've got stuff that you want to know. And the central is the one who looks at that packet, sees it, notices that it's connectable, and says, yep, I do want to hear what you have to say, so let me initiate a connection with you. You can see the microchip documentation provides a sort of connection diagram of what's going on here. So we've got peripherals orbiting around the central that connects to a bunch of them. Now, it's important to note that a lot of the time I've seen this actually decoupled from the roles that they perform physically. So you would think that you have one central device, which is maybe a smartphone or a desktop computer or a laptop, and you have all these embedded peripherals that are out in the world advertising themselves. And that's sort of how it works. You've got the central, which is what makes sense. It's a desktop or a laptop, and you've got peripherals, which make sense. They're the embedded ones. I've oftentimes seen it the other way around. So I've seen it the case that you have embedded peripherals that don't advertise themselves, but instead look for an advertisement packet from a control device, like a phone or a desktop computer or something like that. And so in that case, the embedded peripheral, quote unquote, is acting as the central, and the control central is acting as the peripheral. So just keep in mind it can be decoupled from the physical roles that they play. Hands up if you've ever seen one of these before. This is a UUID, a universally unique identifier, and I'm going to have to use it in order to explain generic attribute profiles to you. So we've explored GAP roles and such, which is essentially just I'm negotiating a connection between 2 Bluetooth devices, what kind of roles can they play and such like that. But after I've formed the connection, how do I actually interact with the device? How do I explore what it has to offer, and how do I, send and receive information to it? And that's where generic attribute profiles come in, or GATT. So to explore this, I have this little draw.io diagram that I've done up to explain this to you. And so there are 2 GATT roles that are of importance at the top level. That is the GATT Server and the GATT Client. So the GATT Server is the part of the device that is actually offering up services for me to interact with. So for example, if I connect to a temperature sensor, the temperature sensor may offer a GATT service that provides the current temperature. If I've got a blood pressure reader, then it might offer a service that allows me to read the blood pressure. So I understand all of this service stuff now. The services are essentially just like endpoints. If you guys are familiar with HTTP and stuff like that, you can think of the GATT services as endpoints. So at the very base, I have a Bluetooth Low Energy device that I've connected to, and it has spun up a GATT server for me, and that GATT server is providing a bunch of these different characteristics. And again, you can think of this as a web server, and these are like endpoints in the web server. It's a similar sort of paradigm to that. Now I need to actually go one step further and describe what kind of operations are able to be performed on these services, and that's where these characteristics come in. With a blood pressure monitor, it makes sense that there is only one operation that I can perform on that, which is to read the blood pressure. I can't ask the device to put more pressure on the subject, on like increase the patient's blood pressure. But if I'm having something like a thermostat, it makes sense that I would have a number of different characteristics or operations where I can maybe read the temperature, I can set the temperature, and maybe I can give it a sort of value that says, I want the temperature curve to look kind of like this. So it would make sense that I have a number of operations that I can perform on that service. And that's what the GATT service hierarchy is all about. We have these services that act like endpoints, and the characteristics are more like operations that we can perform on that service. Now, you may be wondering, where do those UUIDs come into this? And actually, the UUIDs are how we define these services in the first place. So every service is represented by a UUID. And you can see here in this example, we have a GATT server service with two services, one with a 16-bit UUID with a number of 16-bit characteristics, and one with a 128-bit UUID with a number of 128-bit UUID characteristics. And so this generator tool, as you can see here, has given me a 128-bit UUID that I could use to start defining my Bluetooth service. Now, here's the thing, guys. When you're developing custom Bluetooth services that are transferring custom data, you can just pick any old UUID you like. But if you're developing a Bluetooth application, there are also these assigned UUIDs that you use for specific things. So this is in the Bluetooth protocol specification, and you can see there are a number of predefined services that if you're making a device that's intended to be compatible and universally cross-platform, that you can expose in the particular format. So you can see here, we've got a battery service. So if I want to expose my current battery level over Bluetooth Low Energy, I can expose this service. There's the blood pressure service we were talking about before. There's a time service. So what's the current time? This is the UUID I have to hit to do that, or the UUID I have to provide if I want to provide that. And there's so many of these. You can have a look at all of these services here. I'll link this into the description, but it defines up essentially common services, but if you're making your own Bluetooth application with your own custom protocol and your own custom data transfer, you can just generate yourself a UUID and go from there. But that's essentially how they're made up. So you have this service which has its own UUID, and then within that, your characteristics have their own UUID as well. Typically, the way that I've seen it done is if you have a base service UUID like this, you kind of change one of these like 16-bit identifiers for the characteristics. So, I have this service UUID, and then maybe this one is what I change to form my characteristic UUID down here. And with regards to GATT roles, because there's also GATT roles as well, as we mentioned, there's the GATT Peripheral and the GATT Server, the GATT Central and the GATT Client. So essentially what this means is this guy acted as the peripheral, so it advertised itself, and it's providing these services. This guy connected to this guy and is trying to access those services. So that's the GAP role and the GATT role. And this was very confusing to me at first. I often coupled these. So I coupled GAP Peripheral and GATT Server and GAP Central and GATT Client because that's typically how they work. But it's actually completely decoupled. You can be a GAP Central and provide a GATT Server, or you can be a GAP Peripheral and be a GATT Client. It's completely up to you. And so that was really tricky for me to wrap my head around because I always, sort of coupled them as in GAP Peripheral, GATT Server, GAP Central, GATT Client, but it can be any kind of permutation you like. So it's great that we've defined up this hierarchy in our services and our characteristics, but what operations are we actually able to perform on them? If we go over here, we can have a look at the GATT operations. These are the things that we can actually do to the characteristics. Now that we've discovered all the services, we've discovered the characteristics, we know what the device is capable of, how do we actually interact with it? So the client can read a characteristic. If I want to read a value, so for example, the temperature, if I want to read the current temperature, I can send a read request for that characteristic, and the server can send me back a value, which could be anything. It could represent the current temperature, the blood pressure, whatever. I can write a value to a characteristic. So for example, if I am sending the server some sort of information, I don't know, if I'm sending it a command like switch off or change the lights to blue, I could write to the light control characteristic and I could say change the lights blue. Bluetooth has a number of things that make it a more reliable transport, and one of those is write acknowledgements. So you can actually do a write request. If you do a regular write request, the server will automatically acknowledge that, but you can do a write without response because this sort of acknowledgement stuff increases latency. So if I'm doing something like streaming a file, and in fact, I've done this in my career, I've implemented some over-the-air firmware update stuff, which is essentially just streaming a file, right? You actually, a lot of the times, do a write without response. After you've transmitted a chunk, you read back a CRC, and if the CRC is correct, then you keep going. Otherwise, you retransmit the chunk. And the latency that you incur from these acknowledgements can actually be pretty bad, especially if you're going to check the CRC anyway. Sometimes you can do write without response. Now, the server is also able to send things to the client. So for example, you can have a notify. So what the client can do is essentially, once the client connects to the server, it can subscribe for notifications. What that means is that it is essentially waiting for the server to send it an information. This is the equivalent of, if I send a read request to the server, but this is event-based. So if the server has an event, so for example, if my temperature sensor sends a temperature update event every 500 milliseconds, if I, as the client, subscribe for that notification, then every 500 milliseconds, I'm going to get a new temperature from the server. And indications here are very similar to notify, but essentially the client just sends back an acknowledgement. So it's kind of the opposite of this write. The client is the one sending back the acknowledgement rather than the server. And now for something completely different. To demonstrate GATT to you, I'm going to do this on a Windows virtual machine that is actually interacting with a Nordic Semiconductor USB device over UART that it then uses to set up the Bluetooth characteristics. The reason why I'm doing this is to show you guys how varied the Bluetooth APIs are out there, but if you understand the base concepts, you can easily map and figure out what's going on. So what this little USB actually does is pretty cool. It shows up as a UART COM port. It's sort of like, USB CDC, and it'll let us talk to it. So what we've got over here is this Nordic library that they've provided and an example. So this one is a heart rate monitor. We're going to have a look at where they set up the advertisement data. So remember, guys, we've got the device name. So it's going to be Nordic HRM. So you remember, guys, we're setting up this raw data packet here. We've got a UUID, so we're going to be advertising our UUID in the packet, so we're going to be looking for that, which is the heart rate service. And if we scroll down here, you'll see we're doing the connectable advertisement type, and this is the key difference between this and the beacons that we were talking about before. So we're actually going to allow central devices to connect to us. So the Nordic USB is acting as a peripheral. If we come on over to services init, you'll see we're adding a BLE UUID for the heart rate service, which is OX180D, and then we're using that in the call SDBLE GATT service add. So we're adding a primary service which is assigned the UUID of this heart service. More interestingly is this characteristic init function over here, and if we have a look at that, we actually set up the characteristics that that server is going to use. So we scroll down here a little bit, you can see we assign one for the heart rate measurement characteristic, and we also give it read and write permissions. Now down here, what we do is we add the characteristic with this function call over here. And here you can see we actually allow you to get notifications on this characteristic. And now after compiling this example, you can see here we just call it with the COM port that our Nordic USB is on. And if I hit enter and start advertising. So theoretically, our USB device is now advertising in peripheral mode a GATT server where we can look at the heart rate. And you can see right here on NRF Connect, I do in fact have the Nordic heart rate service, and it's connectable because the little connect icon came up. Here we are in NRF Connect, and you can see our Nordic heart rate monitor. I'm going to go ahead and hit connect, and we're connected all up. We can see the services that it exposes, and we're interested in this heart rate one. And if I go ahead and hit notify, we are going to immediately start getting notifications, and the Nordic simulator is sort of varying the BPM over time. And because we're in notify mode, we're continuously getting these updates as our client. Bluetooth is actually so sick.